7-6, which we kind of skipped. We did 7-7. Now we're going backwards because you kind of need to know a little bit about the determinant to do inverses. But we're going to learn about the inverse of a square matrix, which it's kind of nice because it allows you to solve equations. So on a test, just so you know, I will probably have you find the inverse of a 2x2 by hand. And I'm going to show you how to do a 3x3 by hand, but you probably won't have to do a 3x3 on your test by hand. Okay, you could use your calculator. Okay, and because I tried to do a 3x3 last night, and it's not hard, but there's a lot of places where you can make dumb mistakes. Okay, so the inverse of a matrix, inverse of a matrix. Here's what they say. Let A be. So in order for a matrix to have an inverse, it has to be a square matrix. First of all, you got to know that. Okay? And so you don't have an inverse unless it's a square matrix. So meaning it has the same number of rows as columns. Okay? So let A be an n by n matrix, an n by n matrix, meaning n rows and n columns. Okay? And let I sub n also be an n by n matrix. Okay, and be an n by n matrix if it exists, because sometimes if it exists, I sub n called the identity matrix. Nope, that's wrong. N by n identity. If I messed up. Let I sub n be an n by n matrix. I messed up. I got to change my words. Okay? Don't copy that. Okay? Called the identity matrix. That's why it's called I. This is kind of weird, but if there exists a matrix A inverse, that's A inverse matrix, it's the inverse matrix of A, such that A inverse times A is equal to I sub n, which is equal to A times A inverse. Okay? Then A like this is the inverse, a lot of words. inverse of A. In other words, so the identity matrix, do you guys remember what the identity matrix looks like?
One diagonal.
Right. If it's a 3 by 3, it's got ones down the diagonal and zeros everywhere else. Okay? Okay? If it is a 2 by 2, then it would have ones down the diagonal and zeros everywhere else. Okay? That's an identity matrix. So if you multiply the identity matrix by any matrix, then you get the same matrix in return. Okay? So what an inverse is, if I take some matrix, right? So here's some matrix A, okay? And if I multiply it by its inverse, A inverse, if I multiply this times this, say it's a 3 by 3, then I get the identity matrix, okay? And it needs to work in both directions. So normally, matrix multiplication is not commutative, right? So you can't switch the parts around. But in this case, in order to show that something is an inverse, if this thing is an inverse of this, then when I multiply this times this, I get I, and if I multiply this times this, I also get the identity matrix. Okay? You understand that? Hello? No? I'll do an example so you will understand it. All right? So it's kind of like fractions, right? If you take 2/3 and you multiply by its reciprocal, right, 3/2, you get 1. So it's kind of like an identity, right? So you're multiplying. The inverse isn't really the reciprocal, but it's analogous to doing that. Okay. So and also note that they have to have the same dimensions and they both have to be square, right? Because if this were like a 3 by 2 and this were like a 3 by 3, I can multiply a 3 by 3 by a 3 by 2, but I can't multiply a 3 by 2 times a 3 by 3. You understand why it has to be square? Because the rows and the columns wouldn't match up. So they both need to be square matrices, meaning they have the same number of rows and the same number of columns. Okay? So, the first thing you're going to see is something like we'll start with an easy one. Show that A and B are inverses. A, which is equal to -1, 2, -1, 1, and B, which is 1, -2, 1, -1, are inverses. Okay? So the way you do that, you multiply A times B and B times A, and you want to show that the result is the identity. Okay? I really want you to do some of these by hand, okay, without your calculator, because it's good practice and you're going to have to do it. And if you just push buttons on a calculator, it's not going to tell you too much, okay? So because this is a 2 by 2 and this is a 2 by 2, what are the dimensions of my resultant matrix going to be? Also 2 by 2, right? If this is 2 by 2 and this is 2 by 2, then the resultant is going to be the outer dimension of this one times the inner, or by the inner dimension of this one. So this one's also going to be 2 by 2. So I'm going to have 4 spots here. And the way I multiply is I take this row and I multiply by this column and I put it here. So -1 times 1 makes what? -1. And 2 times 1 makes 2. And so what's 2 plus -1? 1. Okay? Let's do the next one. I'm going to take -1 times 2 times this column here, right? So -1 times 2 is +2. And 2 times -1 is -2. Whoops, I did that right. 2 times this makes 2, and 2 times this makes -2. So what's +2 and -2? Say 0. 0. There you go. Okay? what do you think is going to go here? If they're inverses, then they'll be 0. So now you take row 2, column 1. So negative 1 times 1 makes negative 1. 1 times 1 makes positive 1. Negative 1 and positive 1 makes 1. Okay? Then I take this, I turn and multiply this. Negative 1 times negative 2 makes positive 2. 1 times negative 1 makes negative 1, positive 2, and negative 1 make 1. So far I'm good. So you understand? Because this is the identity matrix right there. Okay? Then you go backwards. Okay? You have to go in both directions. Just multiplying. So just multiplying A times B is not good enough. You must multiply B times A as well to show. Okay? So I'm going to multiply 1, negative 2. 1, negative 1 by negative 1, 2, negative 1, 1. And you can do the math. It comes out to be the same thing. Just believe me. Do I have to do it? Could you do that? Can you do it?
Yes.
By hand? Easy?
Yes.
Does it come out to be the same? I think it does. All right. So that's it. All square matrices have to be invertible. Okay? So then we have some words that you got to know. Okay? The next word that you got to know is invertible. Okay? Invertible matrix. I mean, it just means that it has an inverse. Because not all matrices have inverse. Okay? Has an inverse. And then the other word is non-singular or non-invertible. Non-singular or non-invertible. Invertible means that it does not have an inverse. Okay? No inverse. Okay, so a lot of times you'll be doing these problems for homework and you'll plug into your calculator, find the inverse, because I'm going to let you use your calculator most of the time, except for a 2x2 and a couple 3x3s by hand. And you'll get an error or a dimension mismatch or something weird like that. You'll get an error, I think. And that's because your matrix does not have an inverse. Because sometimes it's impossible to multiply a matrix by another matrix to get all ones down the diagonal. Okay? So finding the inverse of a matrix. So this is how you do it. Okay? So find the inverse. Finding the inverse. This is how you do it. I'm going to ask you to find the inverse of a 2x2 by hand, and maybe a 3x2. So if you have A equals 1, 4, negative 1, 3, what you do is first you rewrite as an augmented, I'll show you what I mean by that, augmented matrix with the identity matrix on the right side. And 2 is convert the left side by performing row operations. To the identity matrix. The right right side is the inverse. Okay, so this is, you don't know what I'm talking about, but I'll show you. Okay, so you take 1, 4, negative 1, 3, and you draw a dotted line. Okay, and then you put the identity matrix on the right side like this, and you make it into a new matrix like this. Okay, and now what you're going to do, you're going to perform row operations to turn the left side into an identity matrix. When I turn the left side into an identity matrix, the right side turns into the inverse matrix. Isn't that kind of cool? Okay? So what you want to do is, in other words, you want 1's 1, 1 and 1 here, and 0 here and 0 here. But remember that you're performing the row operations on the entire row, not just on this part of it. Okay? So who could tell me what I could do to get a 0 down here? What can I do to get a 0 down here? Add. So take this. We're going to leave the top alone for now. Usually what you want to do is get, let's make sure I wrote that down right. Did I write that down right? I think I wrote that down right. 1, 4, negative 1. Ah! I knew I messed up because it didn't look right to me. Okay? This should be a negative 3. Okay? This should be a negative 3. Otherwise, I would have been like banging my head against the wall. Okay? So I'm going to add over here. I'm going to take row 1 plus row 2. I'm going to add them together, and I get 0, 1, right? 0, 1. And I'm going to add row 1 to row 2. I get 1 here, and I get 1 there. Easy enough so far? Christian, take your headphone out and shut your computer and quit laughing at something that's not meant, please. Okay? Come on. What are you doing? Shut that. Shut that. Okay? We're not here to watch video games. We're here to learn some math. All right. Thank you. All right. So, Christian, what would I do next to turn this in the left side into an identity matrix? What's my next step? Who could tell me my next step? Lily's, I'm sorry, Hannah's going to tell me my next step.
Do you multiply the bottom row by negative 4?
That's what I would do, okay? See, once you get a 0 down here, once you get a 0 down here, it'll stay a 0 if I'm multiplying it and adding it to the top row, right? That's why you want to get a 0 in the columns first, because then when I multiply something, 0 by something, when I add it, it's not going to change this 1 up here. So what Hannah said is I am going to take negative 4, right, times row 2 and add it to row 1, right? And over here I get 0, and, right? What? Here I get 0, right?
Oh, there.
Yeah, here I get 0. I'm going to multiply this by negative 4. Add it to this gives me 0, right? This stays the same. This becomes what up here? Negative 3. This becomes what up here? What does this become? Negative 4. And this down here stays the same because I'm leaving this row alone. And now I have the identity on the left side. So this thing here, see that bad boy right there? That is your inverse, okay? To prove that it's the inverse, I should do it in both directions, but I'm going to just show you. I'm going to multiply negative 3, negative 4, 1, 1 times 1, 4, 1, 4, negative 1, negative 3. And when I multiply those together, I get, let's see, negative 3 times 1 is negative 3, right? Negative 4 times negative 1 makes positive 4. What's negative 3 and positive 4? 1. Woo-hoo! Okay? Then I'm going to take this. Negative 3 times 4 makes negative 12. Negative 4 times negative 3 makes positive 12. What's negative 12 and positive 12? 0. Okay? Guess what happens here? Going to take row 2, column 1. 1 minus 1 makes 0. And here I get 4 minus 3 makes 1. And so far I have proven that that's true. Now, to show that it's actually the inverse, okay? So this is A inverse, I think, okay? To show that it's actually the inverse, I have to multiply in both directions, okay? So just so you know, if you're taking a test and you have to say, prove that it's the inverse, you have to multiply both in both directions, okay? And if you did that, I'm just take my word for it, you would also get that. Okay? Yes, sir. How did I get negative 3 here?
No.
Here. Okay? Because I took the bottom row, right, and I multiplied it by negative 4, because my goal was to get rid of this 4 up here, right? To turn it into 0. So when I take when I take 1, I have to multiply everything in this row by negative 4, right? So negative 4 times this is negative 4 plus 1 is negative. Okay? And negative 4 times this makes negative 4, and negative 4 plus 0 gives you negative 10. You down with that? Okay. Hey! What? Tenzin, quit picking on Nathan. Yes, Sam.
Wait, so when you multiply the bottom by negative 4 and then add it to the top, you just keep it the same afterwards and change the top only?
Yes. Yeah, you're allowed to do that.
Okay.
Keep one row the same and then change everything. Okay? Hey. So there is a shortcut formula. Okay? Whether you want to use it or not is up to you. But there's a shortcut formula for a 2 by 2. Okay? I'm going to show you what that formula is. Okay? Shortcut chess formula for a 2 by 2 for finding a 2 by 2 inverse. Okay? And this is what it is. If you have A equals A, B, C, D, then A inverse is equal to, and I'm not going to give you this formula on a quiz, so if you want to memorize it, you memorize it. A 1 over AD minus BC times D A negative B negative C. What the heck? So what that means, okay? If you have a 2 by 2 matrix, you take, this is the what? What is this down here? How do I get AD minus BC? What's that called? That's a determinant of this matrix. So it's really 1 over the determinant of A. This is another way. This is equal to the determinant A, B, C, D, right? And what you do here is you switch places with these two numbers, and you make these two numbers negative. So some math students figured that out, that's a formula, kind of a cheating formula. Okay? Yes, ma'am.
So we can use that, we don't have to do row operations?
You don't have to do, I'm not sure what I have on the quiz. Yeah, on the test, if it's I'll find out. Okay, yeah, I think I said you could use either way. Yeah, I think I said you can use any way to find the inverse by hand.
Okay.
And this would be one way. Okay? So I like the row operations because it's kind of fun, but it's like a little puzzle. Yes, Sam? Next block day. Test. Okay? So going back, let's just look at this one. What was it? 1, 4, -1, -3. Okay? So 1, 4, So if I were doing this, 1, 4, negative, what did I say, negative 1, negative 3? Was that right? Did I do that right? 1, 4, negative 1, yeah, 1, 4, negative 1, negative 3. So if I want to find the inverse of this matrix, so if this is A, okay, then A inverse, okay, is going to be 1 over the determinant. What's the determinant of this? Is it negative 7?
Oh, no.
It's negative 3 plus 4. 1. Oh, that's easy, right? 1 over 1. It doesn't always come out to be 1 over 1. Okay? Times. All you do is you switch places with these two. You put the negative 3 up here. You put the 1 down here. And then you make these both the opposite. So you put negative 4 here. And you put 1 here. You guys get it? And if I multiply through, I get negative 3, negative 4, 1, 1. And is that what I had for my inverse in the last problem? Okay. It is. There it is. Okay. So that's the trick. Now, just to tell you, this number isn't always going to be, sometimes it'll be some ugly fraction. Okay. And you have to distribute through that ugly fraction. Or you could just leave it outside. Right? No, you need to distribute through that ugly fraction.
How would you do that?
You just multiply every number here by that fraction.
That's
Right? Yeah. Okay, so if this is like 1/2, then this will become negative 3/2. This will become negative 4/2. So,
And on
okay.
a test, do you prefer fractions to decimals?
Yes. Fractions are exact decimals. Rounded off. Yeah. So I'm singing it. Do you want to see how to find a 3 by 3 inverse?
No.
I did it last night. It took me like half an hour to get it right. I just want to show you. So if you were trying to find the inverse of a 3 by 3, okay? You have one on your homework, but I think I'm just going to let you use a calculator. 1, 0, 1, 1, 0, negative 1, 6, negative 2, negative 3. Now, just to remind you, not every single matrix has an inverse. In fact, very few of them have an inverse, okay? But what you'd have to do is you'd have to go like this, and go like this, go like this, and go like this. And then you have to convert this into that, okay? And I did it. You could do it as a challenge. You want to do it as a challenge? We should have you guys do it.
This should be like the bonus problem.
The bonus problem. Convert by hand. Find the inverse of this by hand. So, just let me show you my first step when I did this. Anyone know what my first step would be? My first 2 steps, really. How could I get rid of this 0 here? So what they just took row 2 and subtracted row 1. That's what I did. Okay. So, and the reason I did that because if I take so I'm going to leave this row alone. Negative 1, 0, 1, 0, 0. I'm going to take row 2 minus row 1, and that gives me a 0, 1, negative 1 minus 0. That row 2 minus row 1, row 2 minus 1, row 2 minus negative 1 here. This turns into negative 1, this turns into 1, this turns into 0. Then what we do, guess what we do to get this one down here? We want this to be a 0 too. How could I turn this into a 0? How can I turn this into a 0 here? That's what I did, okay? So you're going to take row 3 minus 6 times row 2. And if I do that, this turns into a 0. This stays a negative 2. 6 times this, positive 6, negative 3 makes positive, or negative, see where you make mistakes there? Okay, that turns into a positive 3. Positive 3? How did I get negative 3? Negative 6. Because it's negative 3 minus 6 times that. It's 6 plus, that'd be 3, right? And this would be 3. I already did something wrong. I'm looking at last night's stuff, okay? This turns out to be 6, right? This turns out to be negative. What? This turns out to, oh, that turns out to be 0. I'm sorry. Okay? That's still 0. Alright, what a mess. Okay? That turns out to be negative 6, positive 6. That turns out to be row 3 plus negative 6. That turns out to be negative 6. What? Oh, oh, I see what I'm doing. I know what I'm doing. So I'm looking at this row 2 instead of that row 2. So you have to look up here. Anyway, you get this is what I got. 0, and I get the right answer eventually. I got 0. I got 6 times row 2. Negative 2, negative 2. Oh, I just left this alone first, okay? And then, anyway, you do, it takes a long time, okay? And you end up getting this at the end. You end up getting 1, 1, 1, 0, 0, 0, 0, 0, 0, 1. And then over here, you get negative 2, negative 3, 1, negative 3, negative 3, 1, negative 2, negative 4, 1. And you end up getting this thing here as the inverse, right? So you have to do lots of steps in row operations. So, but there's lots of places to make dumb mistakes like I just did, right? So we're not going to do that. You want to see how to find the inverse of a matrix by hand? No? You need to know it for your own.
We already did.
What?
We just did.
What? I mean, with your calculator.
Yes.
Okay. Okay. So, with your calculator, okay, you go to second matrix. I'm going to edit it, okay? And I'm going to change that to a 3 by 3 matrix. And then I'm just going to put in those numbers. 1, negative 1, 0. 1, negative 1, 0, 1, 0, negative 1. 6, negative 2, and negative 3. Good. And now I have that. And then all I have to do is second quit. I'm going to take matrix A, second matrix A, and I'm going to raise that to the x to the negative 1 power right there. See what I just did? Hi.
Do you know what a beta form is?
Vitae is like a resident.
It is?
Yeah.
Okay, so if I just send over my resume. that should
Yeah,
be good.
she said she wanted to go.
Yeah, she was like, send
Yeah.
everything over right now, and we should hear back from the math department in like
Yeah,
2
yeah,
days.
yeah, yes. Yeah. Good.
Yeah.
Okay. Okay, so, and you hit enter. There it is. Just like, hey, look, it matches what I have there on the paper that I did by hand last night. Okay? So that's how you find the inverse of a matrix. Okay? Notice, so what's cool about that, so if I take the inverse of the inverse, what should the inverse of the inverse give me? It should give me the original matrix. Okay? Notice also that if I multiply second matrix A, okay? If I multiply second matrix A by the inverse of matrix A, matrix A inverse, what should I get?
The identity.
Boom. There's the identity matrix. Okay? Isn't that cool? Okay. Get it? So, easy enough to do it. So you will have to find the inverse of a 2 by 2 by hand, but not a 3 by 3 by hand. Okay? But now, let's take a 3-minute break. Do you want to take a 3-minute break? I want to teach you how to solve equations using matrices. It'll just take a second. We'll just keep going, okay? So you have time to work, okay? So this is easy. You just have to know, I want to show you where it comes from, okay? Solving, so this is going to be called solving, we're not going to, we're just going to dig deep. This only takes like 5 minutes, okay? Solving a, I don't know how to write or talk or write. Okay, here we go. Solving a system by using the inverse. This is what you're going to like, okay? Using the inverse. Inverse. Okay? So say I have this system of equations. 2x plus 3y plus z equals -1. And the next equation is 3x plus 3y plus z equals +1. Make sure you can tell that's a y and not an x. Okay? And the next one is 2x plus 4z, I mean 4y, sorry. 4y. 4y plus z equals -2. So you guys are probably already adept enough to solve this pretty quickly by hand, right? But equations can get really complicated. You could have a 4 by 4 system or a 5 by 5 or a 3 by 3 that you've never seen before, okay? And so you can remember from the other day, I can rewrite this as a coefficient matrix 2, 3, 1, 3, 3, 1, 2, 4, 1, a coefficient matrix times a variable matrix, okay, x, y, z is equal, remember we rewrote a system of equation as matrices, okay, at equals the constant matrix, okay, 1, 1, -2. So we're not done yet, okay. I want to get rid of this here because I want to find what x, y, and z are, right? So if I multiply this, so if I call this matrix A, and I multiply by the inverse of matrix A, okay? If that's A inverse, what is this going to turn into? That's going to turn into the identity matrix. The identity matrix times XYZ is going to give me what? The identity matrix times XYZ is going to give me what? XYZ, right? The identity matrix is like multiplying by 1. So if I multiply this times this, I get the identity matrix. And that identity matrix times this is still xyz. But if I multiply the left side by the inverse, what do I have to do to the right side? You have to use the rules of algebra, so you also have to multiply this by A inverse. So I'm going to move this over. Can I do that? I'm going to move this over. And I'm going to multiply this by A inverse times this negative 1, 1, negative 2, because you have to multiply in the same order, right? So this times this is going to give you I, right? And I times this is going to just give me xyz, and this times this is going to give me some number, right? So if I multiply the inverse of this matrix times the constants, I'm going to get x, y, and z. See that? Because this kind of cancels out, right? It's like multiplying by the reciprocal. Okay, so I get x, y, z equals the inverse of this times that. So this is how you do it on your calculator. You just plug in to your calculator these numbers, okay, in matrix A. So in matrix A, I'm going to put in second matrix A, which is still a 3 by 3. Whoops, I messed. Second matrix, we have to edit matrix A, okay? And I'm going to put in the numbers. What are the numbers? 2, 2, 3, 1, 3, 3, 1, 2, 4, 1. Sam, get off your phone, okay? So there's matrix A. Then I'm going to go second quit. And I'm going to put in second matrix B, okay? Which is going to be, what's the dimensions? Whoops, I have to edit it. What's the dimensions of matrix B going to be? What's the dimensions of matrix B? What's the dimensions of this matrix over here? 3 by 1, okay? 3 by 1, right? And I'm going to put in the numbers. Negative 1, 1, negative 2, okay? So there's matrix B. So now I'm going to go second quit, and I'm going to multiply the inverse of matrix A times matrix B, okay? So I'm going to go second matrix B, oops, second matrix A, inverse times second matrix B, and I get the answer. That's x, y, and z. Okay? X is 2, y is negative 1, and z is negative 2. Isn't that cool? It's okay. It's great! All right. Okay. That was Tony the Tiger, in case you didn't know. Okay?